In this video, we will be discussing about count ways to build good strings. Given the integers 0, 1, low and high, we can construct a string by starting with an empty string and then at each step perform either of the following. Append the character 0 0 times, append the character 1 1 times. This can be performed any number of times. A good string is a string constructed by the above process, having a length between low and high inclusive. Return the number of different good strings that can be constructed satisfying these properties. So what they are saying is that in the input, we are given four integers. One is low, high, 0 and 1. So we need to build a string whose length has to be between low and high. And low and high is inclusive, right? So this is 2, 3. So the length can be between 2 and 3. It can be either 2 or 3, right? If high was 5, then our length could be either 2, 3, 4 or 5, right? So we need to create a string whose length has to be between low and high. Now, for creating this string, what is the step that we have to follow? Our string can only contain 0 and 1, right? We will be starting with an empty string and we will append a 0 or 1 on the basis of some condition. So the condition is that a 0 can be appended to the string only these many times, right? Basically in one operation. Whenever we are appending a 0, we will append it these many number of times, right? So if let us suppose that I need to create a string of length 3. So in one operation, I will append 1 0 because the number of zeros that are given to us is 1. Then in the second operation, I will append 1 0. Then the next operation, I will append 1 0, right? But if this was 2, right? If this was 2, in that case, I would append two zeros at a time, right? And similarly for 1, 1 has to be appended these many number of times, right? So these variable names are a little confusing. So these are the number of times that 1 can be appended and these are the number of times that 0 can be appended in one operation, right? So now we need to identify that how many different strings are possible, which are formed using these constraints and whose length is between low and high. So that count the number of different strings that we need to return as our answer, right? So see, what we said was that initially we will be starting with an empty string, right? That's not a space, an empty string. So now for this, when we have started with an empty string, we are having two choices, right? Either we append 0 or we append a 1, right? So when we are appending a 0, it has to be appended one number of times, right? So we'll append a 0. And if we append 1, then it has to be appended two number of times. So we will append two ones over here, right? Now we see here the length of the string is 1 and here it is 2, right? So this is one of the possible string because low is 2, right? We will see how are we going to calculate. So here when we appended a 0, now for the further positions, we again have two choices. One is that we append a 0. If we are appending a 0, then we will append it only once. And if we are appending a 1, then two ones have to be appended because of this, right? So this is what our string will look like, right? Again, we are having two choices here. So if we append 0, then it will become like this. And if we append 1, then it will become like this, right? Then again, here we are having two choices. If we append a 0, we'll get four zeros. If we append a 1, we will get two ones, right? Now, if you see over here, the length of the string has become 4, which is greater than high, right? So there is no point of going beyond this, right? Because the maximum length of the string that we want is high, right? So this will return us a 0. Why? Because this length is larger than high, right? So we are not going to count this string. That is why this is returning a 0. And same goes here, the length is 5. So this will also return a 0, right? But now if we see over here, here the length is 3, right? Which is within the range that we wanted. So this string has to be counted, right? So this string, its count will be 1. So in this one, whatever it has got from the left and whatever it has got from the right, we will add them and then we will return, right? So this will return 1 plus whatever you got from the left, that is 0, and whatever you got from the right, that is 0, right? So this is going to return a 1. And if you see over here, the length is 4, which is greater than high, right? So this will return a 0, Now in this particular case, this is 0, 0. The length is 2. It is within the range, right? So this string has to be counted. So plus 1 for this string and whatever we have got from left and right. So it will be 1 plus 1 plus 0, that is 2. So this is going to return us a 2. Then this its subtree will also receive some number, right? Whatever that number will be, these will be returned as 2 plus x. This will not be counted because here the length is 1 and that is not within the range of low and high, right? So this is how we can solve this problem by recursion, because at every point we are having two choices. Either we are appending a 0 these many number of times, or we are appending a 1 these many number of times, right? Now whenever appending 0 or 1 makes the length of the string higher than this high, then we can return from there a 0, right? So that is our base case, right? If in any case the length becomes greater than high, we will return a 0. And the other thing is that whenever the length of the string is within this range, we need to count it, right? So basically what you will be doing is that, let's suppose in your recursion you took a variable count, right? You will initialize it to 0, and then in the count you will add whatever you will get from the left subtree, right? Whatever you will get from the left, that is by appending 0, and whatever you get from the right, that is after appending 1, right? And in this count you will also add a 1 only if your length is between low and high inclusive, right? So basically 1 will be added only when the length is within this range, right? And also we need not to build this string at every point, right? By the length only we can solve this. Why? Because if at this point my maximum elements can be 3, right? So this is 0, 0, and then one element has to be inserted here. Now for inserting an element over here, I don't care what is present before it, right? Anything can be present before it. At this position, the candidates are 0 or 1, and that we are already identifying, right? Whatever is present before it, that I don't care. So for that reason, there's no need of creating this string. We can just maintain the length of our string, right? So at this point, the length will be 1, here it will be 2, here it will be 2, 3, 3, 4, 4, and 5. And then with this length, we can check that, okay, here the length has become greater than high, return a 0. Length has become greater than high, return a 0. Here the length is 3, which is within the range, add a plus 1 and then return, right? So this is what we can do, right? And another thing to notice over here is, if you see these two cases, right, our maximum length can be 3, right? In both of these cases, there is one place that we need to identify, right? 0, 0, and then this one place, 1, 1, and this one place, right? In both of these scenarios, we need to identify that what will be the different number of ways for this particular position, right? So this is a sub problem. If for the last position we have already identified the answer, then there's no need of identifying it here again, right? So it also involves a sub problem, and because it involves a sub problem, while we write a recursive code, we can also apply memoization, right, to make our code efficient, right? So let's quickly look at the code to understand. So as I said, in our recursion, we will be maintaining the length of our string, right? So we will create a helper function in which we will pass the length. So initially we are starting with an empty string, so we can keep the length as 0, and the other variables we will pass as is, which is low, high, 0, and 1, right? And this is going to return us the number of different strings, so we can directly return it from here. Then we are going to create this helper function. So it is receiving the length, then it is receiving low, then high, then 0, and then 1, right? Now inside this, what is going to be our base case? So our base case is that if my length has become greater than high, then return a 0, right? Otherwise, come here, we'll declare a variable, let's suppose res, we will keep it as 0 initially. Now we need to check that if our length is within the range of low and high, then we need to add a plus 1, right? So we can check that if the length is greater than equals to low, then in result add a 1, right? We didn't put a check for high over here, that it should be less than equals to high, because that condition is already over here. If our length in any case is greater than high, then it will return from here itself. It will not come here, right? And if it is coming to this statement, then that means length is less than equals to high, right? So there is no need of putting that condition. There's no harm in putting, but it's not required, right? So if the current string has a length within the range, we have counted it in res, right? Now we need to count for the further positions, that if I append a 0, then what is the number of strings that I am getting, or if I append a 1, then what is the number of strings that I am getting. So in the result, I will add whatever helper function is returning me, and in this, in the length, I will add 0. Why? Because if I am appending a 0, then 0 has to be appended these many number of times, and if I am appending a 0 these many number of times, so my length will increase by this many number of times, right? And the other things are going to remain as is: low, high, 0, 1, right? And similarly, we will do for 1. We'll call the helper function. The length will be length plus 1, and then low, high, 0, 1, right? And then we can simply return this result. Now in the question, it is mentioned that this count can be large, so we will do a modulo of it with 10 to the power 9 plus 7, right? So this is what our recursive code looks like. Now this code would take a lot of time because it is solving 2 to the power n problems. N here is high because high is a maximum length. Whenever the length is exceeding high, then we are returning it, right? So we will memoize it. So for memoization, if you see, the only thing that is changing over here is the length. So we only need a 1D DP. We will create a normal vector for our DP, right? And what will be its size? So since our length can go maximum to high, we will take the size as high plus 1. And initially all the values will be minus 1. And then here we can pass this DP. Here in the helper function, we will receive it, right? Then whenever we are calling our helper function, we will pass this DP. And then after our base condition, we'll check that if this particular length in DP, its value is not equals to minus 1, then return it, right? And here before returning, we will update it inside our DP. Right? So this is what our code looks like. Now, since we are filling our DP with this recursion and we are also not solving the subproblems again and again, the size of the DP is high plus 1. So here the time complexity of our code is order of high, right? And what about space complexity? Since we took a DP vector, right, whose size is high plus 1, so the space complexity is also order of high. 1 is a constant plus 1, so that's why we have removed this, right? So let's run this code. The test cases are accepted. Let's try to submit this. So it has got accepted. Now let's try to discuss the top-down approach for solving this. So this was the memoized approach that we saw. Now let's discuss the top-down approach for this. So what we will do is that we will try to fill this DP iteratively, that is without recursion, and we will fill it top-down, meaning we will start from the starting and then we'll go towards the end of this DP, right? So for starting from the starting, we will need some base case, right? So in this DP, what is the key telling you? What is the index? That what is the length of my string, right? We are updating length over here, right? So the key is telling me that what is the length, and the value is telling me that how many different number of ways are there for this particular length, right? So for the base case, what I will do is in DP at the index 0, I will put a 1. Why? Because it is denoting that for a string of length 0, there is only one possible way of forming it, right? For an empty string, there is only one possible way, that you do not append anything, right? So this will be my base case, right? Now what I will do is that I will simply start filling this DP. I'll start my I from 1 because the 0th index we have already filled, and then I will move my I till high, right? And then we'll do I plus plus. Now inside this, at DP of I, what am I going to store? So here in the length, we were adding 0 and 1, right? But here, since we are going top down, we are starting from the starting and then we are going towards the end, right? So this 0 and 1 would be present before this particular index I. So instead of doing plus, we will have to do a minus. Basically, we will do DP of I minus 0 plus dp of I minus 1, right? This is what we will do if we followed the bottom up approach. That is, we started filling our dp from the end. In that case, we would do I plus 0, I plus 1, because the sub problem solution would be present towards the right of the current index. But in this particular case, we are starting from 1 and then going towards the high. So the answer of the sub problem would be present to the left of index I, right? And now, since it might be possible that this particular index does not exist in our DP, so we will have to put a condition for it. So let's just remove this. Now inside this, first we'll check that if I minus 0 is greater than equals to 0, only then we will consider dp of I minus 0, otherwise we will take 0, right? And then similarly, we'll check for if I minus 1 is greater than equals to 0, then take dp of I minus 1, otherwise consider a 0, right? And then this entire thing will do a modulo with 10 to the power 9 plus 7. Now after this, our dp vector will be filled. Now for the answer, should I return dp of high? No, because dp of high would be containing the number of different strings for the length equals to high. But we need to return the number of strings where the length is between low and high, right? So what we'll do is, let's create an answer variable and then we'll run a for loop of I starting from low and we will go till high. And then we'll do I plus plus, and in our answer we can simply add dp of I, and then we'll also do its modulo with 10 to the power 9 plus 7, and then here at the end we will return the answer, right? And this helper function we can remove. So with this in our answer, we will sum up all the different number of strings that we are getting between these lengths, right? So if my low is 2 and my high is 4, so it will sum up the values for 2, 3 and 4, and then that is what we are returning, right? So again, time complexity, if you see here, we are running a loop from 1 to high and then here from low to high. So these will be added. This is more dominating, so the time complexity will be high itself and the dp vectors still exist, and this is the only space that we have taken, so the space complexity is also the same. Let's submit this. So here we forgot to put a colon. Let's try to submit this again. So it got accepted. Thank you so much for watching. Please like the video and subscribe our channel.